This video is for all my Calculus 1 students, both in person and also you guys on YouTube. Because when I first gave them this limit question, many of them didn't know what to do. I know it kind of looks scary. And some of them would just try to use L'Hopital's rule, but that will end up really badly too. Because if you just keep taking the derivatives, yeah, it's not going to be fun. So here is a better way to do it. First, if you put 0 into all the x's, we do get 0 over 0, but don't do L'Hopital's rule yet, because we have square roots on the top. So maybe let's try to multiply the top and bottom by the conjugate and see what happens. So when we do that, we will have the limit as x approaching 0. Well, the top is just a minus b times a plus b. The result is a squared minus b squared. So we just square the first term, square root cancel. We will just have the inside 1 plus tangent x minus b squared, which again is just going to be the inside. And now be careful for the second part. Make sure you put them in parentheses because you have to distribute the negative. And then the bottom right here stays the same. And now if you take a look right here, it looks like I kind of make this even worse, because if you use L'Hopital's rule now, you will have to use the product rule for the denominator. That's pretty bad. But in fact, you don't have to worry about that. Here we are going to utilize some of the limit laws. Check this out. Firstly, on the top, let's simplify it. 1 minus 1 is just 0. That's nice. And we will just have tangent x minus sine x. So that's also kind of nice. But notice tangent x is the same as what? Sine x over cosine x. Okay, keep all that in mind. First, I'm actually going to look at this part right here. Because if you take the limit as x approaching 0 of this part, it turns out to be pretty nice. And here's the limit law that we are going to use. The limit of a product is equal to the product of the limit, assuming the limits exist. So what I mean by that is, I'm actually going to first take a look at the limit as x approaching 0 of just this part on the bottom. This right here is going to be really nice. When you plug in 0 into here and here, they will just be 0. So it's square root of 1 plus square root of 1, which is 2 on the bottom. So in fact, this part will just give us 1/2, and then we're done. You don't have to worry about that. Good. Now, we have sine x. I'm going to factor that out. And again, I'm going to look at this as a limit by itself in here as well, as x approaching 0. Factoring out this, we have sine x. But guess what? On the bottom, we have x cubed. I don't want that. I want just x to the first power. Because this is perhaps one of the most famous limits, this will just give you 1. Right here, you can do some geometry proof for it. Yeah, that's all I'm going to say. And then let's look at the rest. We have the limit as x approaching 0. Now we have just 1 over cosine x, because we factor out the sine, right? So that will give us secant x. Okay, 1 over cosine, it's a secant x here, minus sine x is out right here already, so it's minus 1 over x cubed. We took 1 out right here already. Right here, we just need the square. And now we just have to figure out this. And then L'Hopital's rule. This is so much better. So if you just focus on this part, by using L'Hopital's rule, we will get the limit as x approaching 0. Differentiate secant x, we get secant x times tangent x. And then differentiate x squared, we just get 2x. Yes, you still end up with 0 over 0, but you know what? Tangent x is sine x over cosine x. So let's fix that right here. And what we will do is use the limit law again. We will look at the limit as x approaching 0 sine x over x. And once again, this is just going to be 1. And then the rest is what? Here we have the limit as x approaching 0, and we have secant x, and this is also secant x because 1 over cosine. So here we have secant square x over 2. Guess what? This right here is just going to be 1. And this right here, you don't even have to do anything fancy. Plugging 0 into the x, secant is the same as 1 over cosine. Cosine 0 is 1. This is just going to be 1. 1 squared is still 1. And multiplied by, well, divided by 2. So altogether, we just have 1/2. So in fact, this part is just 1/2. So, final answer, 1 over 4. That's it. So I just realized that you don't need L'Hopital's rule for this limit either. First, you can write secant x as 1 over cosine x, and then we can multiply the top and bottom by cosine x, so that you get 1 minus cosine x on the top, and then x squared cosine x on the bottom. Then I will multiply the top and bottom by 1 plus cosine x. That way, the top is 1 minus cosine squared, which will get sine squared. And as you can see, sine squared over x squared, we can just look at it like the limit as x approaching 0, sine x over x twice, so you have the square, and that will just get 1 square. And then the other part, right, cosine x, and then 1 plus cosine x on the bottom. When you put 0 in here, cosine 0 is 1, and then this will be 1 plus 1, so it's 2. So it's 1/2. So altogether, you just get 1/2. So yeah, you could have done this question entirely without L'Hopital's rule.